We are Dexian, in the business for good.
A dynamic leader in product innovation and customer success. With a stellar career spanning Google, Amazon, and now he's shaping the future of AgriTech with cutting-edge solutions. Let's hear from Abhijit Saha, Head of Product at Cropin.
Thank you, Gates Foundation. Thanks, Dexian, for this opportunity. So far, it has been a fantastic day. I personally had a lot to learn. And I'm glad to have this opportunity to present some of the things we are doing today. Cropin, founded in 2010, we call ourselves a SaaS-based, AI-powered agri-tech company. So we basically work with organizations, including governments, development agencies, and the commercial organizations, seed companies, CPG products, etc., etc. But the problems that we are solving are the same problems that farmers are facing. We have slightly different outlook towards it, but I resonate with a lot of speakers today when we say we need to basically work together to build the AI solutions that actually solves the problems for the farmer. I also resonate what we have said are the challenges related to data, related to quality. Before Cropin, I spent some time in Google. So that was first called Google Assistant team. That became Bard. That became Gemini. That became DeepMind. So essentially, all the AI stuff in Google. And one quick anecdote I can say, just 3 years back when I was working in Google Assistant. So Google Assistant is, hey, Google, set the alarm, right? Just 3 years back, this process was super manual. So when you say, hey, Google, set an alarm, first, there is a team, NLP team, natural language processing team, that converts that voice into just a string, English text string that says, create an alarm. Then there is actually a code written to process that string. So alarm will be a function, there will be code written to extract that function. 6:30 is a time. Then you have some more processing, right? So where is the person, which time zone, based on that, which 6:30. And then that gets converted into SQL, a query, that goes to a function, you create it, and again, it comes back, it gets converted into text, then it gets converted into voice. Super inefficient, and just 3 years back, so not way back. And with LLM models, that changed literally overnight. So within a span of 3 months, that entire stack that was developed across few years, few hundred engineers, became absolute, and it moved to a Gemini model. So a lot of assistant work now happens through Gemini model. So this is the scale of evolution in the company, even like Google, right, which is at the forefront of it. So I can only imagine whatever we are doing now, how childish it will look when you look back at it like 3 years, 4 years down the line. So amazing potential lies in front of us. We just need to figure out where the value is for the farmers, for the companies. So I generally see AI as front-end and back-end work. So back-end essentially are the core models that process the data and converts it into useful output. So in Cropin, for example, we have range of models which are combination of crop, region, and a particular model. So there will be, let's say, a model for Karnataka, paddy, and yield. So this model can predict the yield of paddy in Karnataka. There will be another model which will be Bihar, maize, dews. So this model will predict the possible dew disease and pest attack in advance for Bihar. Why we have this kind of bifurcation? Because even though the crop is same, region-wise the other parameters including weather changes, soil changes, and nowadays climate is also very different. Also, variety-wise there are changes. So what work, if we build a model, let's say for Karnataka paddy, it will not work for Sri Lanka paddy. So all these models has to hyper-tune based on the regional data. So that's the backend. And we have been doing backend work for last 3-4 years, and I think we are getting pretty good at it. But there is also a front end of AI, and a lot of examples we saw today, including chatbots, right? So chatbot is the front end of AI. This allows the interface with this data. I think those who have worked in Bihan or other cases where you have worked with BI models, you will know how complex it is to create the dashboard that gives meaningful information. We are sitting on huge amount of data, but for the policymakers, decision makers, to be able to interpret that data and make decision based on it, right? It is expensive work. A lot of effort has to be spent, and even with that, it creates certain bias. If you build a certain dashboard to present certain data, you're almost leading the person towards a certain decision. And then if you want to change that data, change the viewpoint, it's a huge effort. And that's where, again, I'm excited about the potential of AI. Because the front ending of AI, right? If you have the data available, you can ask n number of questions and you will still be able to get the answer. But let me probably stop talking and show this video. We call this product Crop in Sage. The way it works in the background, we already have identified the regions, we have run the model. Whatever output we get that from model gets stored. So we partner with Google to do this. Here you can see this is China's Guangzhou region for potato. So if you see queries being asked, show me all the potato grids in Gansu in 24. So you put this, here you can already see the grid. Here there is a metadata available. You can see crop area, you can see total crop area in hectareage for the region, you can see average yield. So this came on the fly. This data was already available. We built it on GKE, Google Kubernetes Engine. And then we gridified this data and we stored it in Cloud SQL. So now you can see grid, you can hover on the grid and you can see all the values related to that grid here. Next to that, now this query, right? Show me a region where above average precipitation and average yield above 30 tons. When you put this query, and then we gave specific district, Jinjiang district in Gansu. Immediately you are seeing this data here now. So these are the grids where the precipitation is above average and the yield for potato is above 30 tons. You can get the metadata for weather when you click on, and then you can play with this data. So this is basically BI dashboard for this query. So the benefit of that is instead of building like 100 dashboard, one each district, each crop, precipitation, weather, temperature, yield, acreage and everything, right? All that information is available in the backend. So we store, as I said, we store it in the Cloud SQL. We use Google Kubernetes Engine to gridify it. And then we have built it on top of Gemini model. So Gemini basically gets this text string. It converts it into SQL, queries our Cloud SQL data, and this is the output that we get. The benefit, great benefit. So on the front end, as I said, number of dashboard, number of queries can be asked. This information is available on your fingertip. Some of the problems that AI models face in terms of hallucination or inaccurate data are not here because we gave a very extensive prompt to train this model where we have given the entire database schema. When the question is asked, the answer comes only when that information is available in our database. So if the answer is not available, the model doesn't hallucinate and make up the answers, right? It just says that this data is not available. And then this doesn't have to be done again and again. So we just have to run the model every time. Front-end part is more or less taken care. So this is the part that we are excited about. And now with more front-end models coming up, so I think, as I said, I think we feel like we are getting good at back-end models. We rely on partners to build the front-end models. So this is Gemini-based. But number of models have colloquial languages. And we would love to partner with them so that it becomes accessible to farmer. Last point on in terms of challenges, right? I think it's already mentioned. I don't want to take too much time, but there is a triangle of accuracy, affordability, and value. And unfortunately, you can choose 2 out of 3 as of now. So if it is accurate and affordable, there is less value, like historical weather data. If it is, it has a value and it has great accuracy, then it is very expensive, like commercial satellites which do 20 by 20 centimeter daily runs, right? And if it is value add, it is affordable, accuracy is very less, like the free satellite data. So when we solve this challenge, I think there is a tremendous potential lying ahead of us to work on this industry and fundamentally change the way we are looking at data and consuming the data. So really excited about it and looking forward to working with you all on this. Thanks.
We are Dexian. In the business for good.